This lesson will look at the sublevels, orbitals, and electrons in our completing the model of the atom unit. First of all, the difference between energy levels and sublevels. We learned in our studying of atomic emission spectra and from the Bohr hydrogen atom that atoms contain different energy levels. In other words, that energy is quantized. In other words, an atom could have n equals 1 or be at the first energy level, 2, 3, 4, etc., which we've looked at. And we know that those energies get closer and closer together as we go up in energy. Now note, these diagrams here are not drawn to scale, but they do give us a very helpful visual for understanding this. As it turns out, energy levels do not exist as only one unit. Energy levels contain sublevels, or smaller units of energy within that. So for example, the first level, n equals 1, has just one sublevel. The second energy level, n equals 2, has two sublevels, and I'm representing that here by these two lines. The third energy level has three sublevels, and so on. The fourth has 4, the fifth has 5. So the key idea here is that the principal quantum number, that's n, that's how we designate our energy level, the principal quantum number n indicates the number of sublevels for each energy level. So in other words, if we were talking about the ninth energy level, the ninth energy level would contain 9 sublevels. Now each of these sublevels has a specific letter designation that we need to become familiar with. The first sublevel in any energy level is designated with the letter S. So the first sublevel, and happens to be the only sublevel in the first energy level, is designated 1s. 1 because it's in the first energy level, S because it's the first sublevel within that energy level. We would thus have 2s, 3s, 4s, 5s, etc. If it's the first sublevel in the energy level, it's designated with an S. The second is a P. So notice there would be no 2p sublevel because there's not a second sublevel in the first energy level. The p sublevels wouldn't start until we get to the second energy level. So that would be designated 2p, and then we have 3p, 4p, 5p, etc. The third sublevel for any energy level is designated with the letter D. And like the p's, we don't have a 1d. We also don't have a 2d. The D sublevels would start with the third energy level, so 3D, we have 4D, 5D, etc. The fourth sublevel for any energy level is designated with the letter F. So we have 4F and 5F, there'd be 6F if we were showing a sixth sublevel or energy level, which we're not here, but you get the point. These are actually the only ones that we'll ever have to worry about, the first 4 sublevels for any energy level, S, P, D, and F. However, as you can see from the diagram, and if we were to have more energy levels, there would be many more sublevels. Beyond the 4th sublevel, the letter designations go in alphabetical order. So after F comes G, so that 5th sublevel in the 5th energy level would be 5G. If we had a 6th energy level up here and a 6th sublevel, that would be 6H, and then a 7th sublevel, for example, in the 7th level would be 7I, etc. I think you guys get the point. Alright, so the thing about these sublevels is, even though on the previous slide I'm kind of showing them all as being equal energies, they're really not. Within any energy level, the energies always go in the same order, S, P, D, and then F. Now obviously if you don't have all those sublevels, then you just leave them out. So my example here, I'll show you the 4th energy level, because that's the first one where we have all 4 of these letter designations. So the 4s sublevel would have the least amount of energy, followed by the 4p, which would have a little more, the 4d would have a little more than that, and the 4f would have a little more than that. So while they're all in the same energy level, their energies are a little different, thus we call them sublevels. Now the other thing about these sublevel energies is that they can overlap between different energy levels. So here I have an example between the 3rd and 4th energy levels, and I've just spaced them out a little more over here so it can make sense to us. So let's start with the 3rd energy level. Let's say this here represents the energy of the 3s, and then we know 3p is a little more than that, and 3d is a little more than that. Now let's talk about the 4th level. As it turns out, the 4s sublevel actually has less energy than the 3D. So notice, and I did this intentionally on the diagram, how that 4s sublevel is a little lower than 3D because there is some overlap there. Now you don't need to memorize this one in particular overlap. We will come up with a way later on of being able to determine all these overlaps. This just happens to be the first time it happened, so I want to show that to you. And then beyond 4s we have 4p, 4d, and 4f. So notice, even though the 3D energy level, or sublevel, excuse me, is in the third energy level, it actually has more energy than the 4s because of these different energies for each sublevel. So the key idea here is that the sublevels within any energy level all have different amounts of energy. Alright, a practice question or two here for you. Read the question, pause the video, see if you can answer it yourself, and then play the video to see if you got it right. So the first question, list each of the sublevels in order of increasing energy for the 7th energy level of an atom. So you've had a chance to answer this. Hopefully you recognize that there would be 7 sublevels for the 7th energy level, and then those would be in order from least to most energetic. Would be 7s, 7p, 7d, 7f, and then beyond that, recall they just go in alphabetical order, so 7g, 7h, and 7i. So that whole idea of increasing energy with each sublevel continues beyond F. If we were to keep going, if we had like 10 energy levels, it would be after I, so it would be J, K, L, etc. I forgot the alphabet there for a second. All right, next question. What is wrong with the phrase the 4F sublevel? Hopefully you recognize here that there is no such thing as a 4F sublevel. 3F sublevel. I should read the question right. The 3F sublevel. There is no such thing as a 3F sublevel. The third energy level only has 3 sublevels, which would be 3S, 3P, and 3D. There is no such thing as a 3F sublevel. Alright, moving on to the next topic here. Let's talk about orbitals within these sublevels. So the term orbital, what that refers to is the probable location of an electron in an atom. You might be thinking, wait, probable, why do we need to talk about a probable location? Why can't we just say where the electron is? Well, here's the thing. Electrons, they don't actually orbit the nucleus of an atom like the Earth orbits the Sun. That is a very helpful visual, especially when we're learning about the Bohr model of the atom and atomic emission spectra, but that's just not how they work. In fact, as it turns out, it's impossible to assign any fixed path to tiny particles such as electrons. We really cannot say exactly where an electron is at any one time. Now we can determine probable locations, thus we talk about orbitals. As it turns out, each type of sublevel, so in other words S, P, D, and F sublevels, they each have a different number of orbitals. And it goes like so. S sublevels have 1 orbital. That's whether it's 1s, 2s, 7s, it makes no difference. If it's an S sublevel, there is 1 orbital in that sublevel. P sublevels have 3 orbitals. Again, 2p, 4p makes no difference, 3 orbitals. D sublevels have 5 orbitals, and F sublevels have 7 orbitals. So notice the pattern, 1, 3, 5, 7. If we were to go beyond F, and again we will never need to, but if we were, the pattern would continue. In other words, a G sublevel would have 9 orbitals, an H sublevel would have 11, etc. Now you might be wondering, how can we remember this? What is it going to be, just something I have to memorize? Well, not really. So first of all, the key idea here. Each type of sublevel, S, P, D, and F, has a different number of orbitals. And an orbital is the probable location of an electron. So as far as how to help you remember this, here's a very helpful visual that I found over the years that students really like. Use boxes to represent the orbitals. Here's what I mean by that. Let's talk about the 1s sublevel. We just said that any S sublevel has 1 orbital. So I'm going to draw 1 box to represent that 1 orbital. Now let's go to the 2s. Well, it's an S sublevel. The fact that it's 2s makes no difference. It's an S sublevel, so it has 1 orbital. So I draw 1 box. 2p sublevel Because it's a p sublevel, it has 3 orbitals. So I draw 3 boxes, as you can see there. Now I keep going up my energy levels here. I get to 3s. Again, s sublevel, 1 box, 1 orbital. 3p, well, it's a p sublevel, just like 2p, so there'll be 3 orbitals there, 3 boxes. Now we get to 3d. Based on our pattern, we have 1 orbital in an s, 3 orbitals in a p, that's 5 orbitals in a d, so I draw 5 boxes to help me remember that. And then same thing with my f, my 4th energy level, and I'll get to f in a second. For s sublevel would have 1 orbital. For p sublevel would have 3 orbitals. For d sublevel would have 5 orbitals. And then my 4f sublevel would have 7 orbitals. Just continuing the pattern. 1 orbital in the s's, 3 orbitals in the p sublevels, 5 orbitals in the d sublevels, 7 orbitals in the f sublevels. I'm only showing the 1f sublevel here, but if I had 5f, it would also be 7 orbitals. So that's a very helpful way to help you be able to remember how many orbitals are in each sublevel. So here are a couple of practice questions for you regarding orbitals. Determine the number of orbitals in each sublevel. So look at each of those. Think about the previous slide. If you need to go back in the video and look at that, please do again. Answer each of these, pause the video, and see if you got them right. All right, the first one there, the number of orbitals in each sublevel. A, the 2s sublevel, just 1 orbital. It's an s sublevel, so it's 1 orbital. B, the 4s sublevel. The fact that it's now 4s makes no difference. The only thing that matters is that it is an s sublevel, so that's 1 orbital. Next we have the 7d sublevel. Well, that's going to be 5 orbitals. Again, what you're worried about isn't the fact that it's 7d, just that it's d. Any d sublevel, 5 orbitals. So likewise for question D, the 3d sublevel, that would be 5 orbitals. It's a d sublevel. Question E, 28f. Sometimes that 28 might look confusing. It can be intimidating. It doesn't matter. If it's an f sublevel, it has 7 orbitals. Finally, 5p, p sublevels have 3 orbitals. If these were difficult for you, if you got some of these wrong, I would encourage you to go back and look at the previous slide with the boxes. Just practice drawing that out. There's a clear pattern there. If you practice drawing it for just a few minutes, you will get this down very quickly. All right, now let's talk about electrons, because after all, orbitals are the probable location of electrons. So we'll just start off with a very key idea here. Any orbital, it doesn't matter what the type. If it's s, p, d, f, we go g, h, i, makes no difference. Any single orbital, notice we're talking about an orbital, not a sublevel. Any individual orbital can hold a maximum of 2 electrons. So because every orbital can hold 2 electrons, and again, doesn't matter whether it's s, p, d, or f, each sublevel then, as a whole, has a maximum number of electrons it can contain. Let's just take a look at this table here to help us understand this. So recall that any s sublevel, again, whether it's 1s, 2s, 7s, makes no difference, is going to have 1 orbital. Well, what we just said there, any orbital can have a maximum of 2 electrons. So if we have an s sublevel, we have 1 orbital, it can hold a maximum of 2 electrons in that whole sublevel. If we're talking about the p sublevel, we know that p sublevels have 3 orbitals. Well, each of those orbitals can hold, again, 2 electrons maximum. So in the entire p sublevel, there can be 6 electrons, 2 electrons maximum in each of 3 orbitals. 2 times 3 is 6. Continuing with this idea, a d sublevel has 5 orbitals in it, so it can hold a maximum of 10 electrons. 2 electrons maximum in 5 orbitals makes 10 electrons. And finally, an f sublevel has 7 orbitals in it for a maximum of 14 electrons. So the key idea here, 2 electrons per orbital maximum. Note that is a maximum. You could have less. Orbitals could have 1 electron. They could also have no electrons. That is possible. And each sublevel type, s, p, d, and f, also has a maximum number of electrons then, because they each have a different number of orbitals. But again, you might be wondering, how can I remember this? That seems like it's a lot of memorization. Well, let's go back to our boxes idea, and I'll add to that, we can use arrows to represent electrons in these orbitals. So here's that same diagram we had from before. We're showing our sublevels, and remember, each individual box represents a different orbital. So there's one orbital in each S sublevel, there are 3 orbitals in each P, etc. Well, let's draw an arrow in a box to represent an electron. Now I'll start down here with the 1s sublevel, and I'll draw an up arrow to represent the first electron that goes in the orbital, and a down arrow to represent the second. There is a significance, those up and down arrows, and we'll get to that later in our learning in this unit. For now, we don't need to worry about that. Just know, once you have an up arrow and a down arrow, that's your maximum, because that's 2 electrons, and you have to move on. So I can see for any S sublevel, whether it's 1s or I go up here to 2s, I put my 2 electrons in it, that sublevel is full. So any S sublevel can hold 2 electrons. Now let me go to my 2p here. Well, each orbital can hold 2 electrons. So notice I have 2 electrons in this first orbital. I can't put any more electrons there, but I still have 2 more orbitals left. I can put 2 electrons in each of them, for a total of 6 electrons in the 2p sublevel. And that will be the same case with 3p and 4p. So I can continue here, and I'll just click through and fill up each of these. So notice my 3s has 2 electrons maximum, my 3p has 6, my 3d has 10, because there are 5 orbitals there, so 10 electrons maximum. My 4s has 2 electrons maximum, in the 4p there are 6, the 4d there are 10, and then finally we get to this f sublevel 4f. Notice there are 7 orbitals there, so a maximum of 14 electrons that can go there. Alright, again a practice question here. Determine the maximum number of electrons in each of the following. So pause the video, answer the questions, see if you got them right. Alright, first one, we have a 3p orbital. The maximum number of electrons in a 3p orbital would be 2. Notice this particular question asks you about a single orbital. It's not asking you about the entire sublevel. So in any orbital, whether it's a 3p, a 7f, a 28q, makes no difference. It's going to be 2 electrons maximum. Question B, the 3p sublevel. So note the difference here. Question A was about a single 3p orbital. Question B about the entire 3p sublevel. Well, any p sublevel has 3 orbitals, so that's a maximum of 6 electrons. Moving on here. Question C, the 5d sublevel, that would be 10 electrons maximum. 5 orbitals in a d sublevel, 2 electrons per orbital maximum, 10 electrons in total. Question D, the 2s sublevel, well, that's going to be 2 electrons. You might be saying, but wait, that's the entire sublevel. Why is it only 2? Well, remember, any S sublevel only has 1 orbital in it. So that 1 orbital can just contain the 2 electrons. Likewise with question E, a 2s orbital. It's an orbital, any orbital, maximum of 2 electrons. Question F, a 6f orbital. Again, the question is asking about a single orbital, maximum of 2 electrons. Finally, question G, the 4f sublevel, the entire sublevel. Remember, f sublevels have 7 orbitals, so that is a maximum of 14 electrons in any f sublevel. Alright, last couple of things here to help us finish up our understanding of electrons, orbitals, and energy levels. So here we have that same diagram we had before. It'll be helpful for us as we look at the information on this slide. Question. What is the relationship between the energy level and the number of orbitals on the energy level? So this question is not asking you about any particular sublevel. It's asking you about an entire energy level. So in the first level, how many orbitals are there? In the second energy level, this entire energy level, how many orbitals? In the third, how many are there? Well, let's take a look at that. So the first level has 1 orbital. We can see that very clearly here. There's only the 1s sublevel, 1 orbital there. The second level has 4 orbitals in total. I have 1 orbital in the 2s. I have 3 orbitals in the 2p for a total of 4. So that's 4 orbitals in the second level. The third, you probably already counted it, has 9 orbitals. I have 1 in the 3s, 3 in the 3p, 5 in the 3d for a total of 9. So look at the pattern here. We have 1 orbital in the first level, 4 in the second, 9 in the third. What is that pattern? Hopefully you have recognized this, that the number of orbitals on any energy level is the square of the principal quantum number n. Remember, that principal quantum number just tells you the energy level. So if I have the 4th energy level, my principal quantum number is 4. 4 squared is 16. If you count it up, there are in fact 16 orbitals there on the 4th energy level. So we could just come up with a handy table here, and we could certainly add more numbers to this if we needed to. But you see the relationship here. The energy level, or the principal quantum number n, 1, 2, 3, 4, 5. The number of orbitals in that would be the square of that, 1, 4, 9, 16, 25, etc. All right, lastly, let's talk about electrons and energy levels, because after all, it's electrons that go in orbitals. What is the maximum number of electrons that can go in any energy level? So just remember this from the previous slide, or slides, I should say. We know that a maximum of 2 electrons can go in any orbital, and that every energy level has the number n squared orbitals. So if I think about that, and I can count my boxes up here too to help me, we can figure out how many maximum electrons go for any energy level. So notice for the first level, I can put 2 electrons there maximum. There's 1 orbital there, 2 electrons in that orbital, maximum of 2. For the second level, it would be 8, because there are 4 orbitals, 1, 2, 3, 4, 2 electrons maximum per orbital. That would be 8 electrons maximum on the second level. The third would be 18, 9 orbitals, 2 electrons maximum per orbital, makes 18 electrons. Again, there's a very clear pattern here. Hopefully you've recognized it. Notice that all we need to do is we need to take the number of orbitals on any energy level, which is n squared, we came up with that on the last slide, and multiply it by 2. So the maximum number of electrons in any energy level is 2n squared. And here again is a table to help us understand that. The first 2 columns are exactly the same as the previous slide. Here's our energy level. Here's the number of orbitals. Again, that's n squared. And then the maximum number of electrons for that energy level would just be 2 times that number n squared. And so you can see those values there. All right, several review questions here. I'll go through these fairly quickly, but after each question, do pause the video, answer it, and then play it, see if you got it right. If you didn't get it right, I would flip back to the video and find that section to help you understand it a little better. All right, question 5. How many sublevels would be present in the 6th energy level? What are the letter designations of those sublevels? List them in order from least to greatest energy. So there are 6 sublevels in the 6th energy level. The sublevels from least to most energetic are 6s, 6p, 6d, 6f, and then 6g and 6h. Recall, after f, they go in alphabetical order. We actually really don't deal with those hardly at all, really ever, so we don't need to worry about them. All right, what is an orbital? What is the maximum number of electrons that can go in any orbital? An orbital is the probable location of electrons in atoms. A maximum of 2 electrons can go in any orbital. How many orbitals are in the 5d sublevel? The 6p, the 4s, the 9f. So recall that there are 5 orbitals in any d sublevel, whether it's 5d, 3d, makes no difference. There would be 3 in the 6p, 1 in the 4s, and 7 in the 9f. Recall drawing the boxes can help you visualize the number of orbitals for each sublevel. Question 8. What is the maximum number of electrons that can be placed in the 3d sublevel? The 7f sublevel, the 3p orbital, a 99q orbital, or the 3p sublevel. So the 3d sublevel, there'd be a maximum of 10 electrons because you have 5 orbitals in any d sublevel, so 10 electrons maximum. 14 electrons could go in the 7f sublevel. Remember, 7 orbitals per f sublevel. 2 electrons in a, I should say 3p orbital there. Looks like I had a typo. So this question is about a single orbital. And in any orbital, you can put 2 electrons maximum. We could put 2 electrons in a 99q orbital. The fact that it's 99q makes absolutely no difference. Again, any single orbital, 2 electrons maximum. And then finally, 6 electrons in the 2p sublevel, because any p sublevel has 3 orbitals. All right, question 9. How many orbitals are on the 7th energy level? Hopefully you remembered that for any energy level, the number of orbitals is n squared. So here n is 7. 7 squared would be 49. So there are 49 orbitals on the 7th energy level. And last question. What is the maximum number of electrons that can be placed in the 8th energy level? Hopefully you remembered that the maximum number of electrons for any energy level is 2n squared. Here, n squared would be 64. 8 times 8 is 64. So there'd be 64 orbitals times 2 electrons per orbital gets you 128 electrons that we could put on the 8th energy level maximum.